Hello guys, today we will see how to create a intersection design in Civil 3D. First of all, I have created one drawing in metric standard template so that I will get all the pre-loaded layers and the styles. For example, preloaded surface styles or any other style for that matter, label style, stuff like that. So in order to get started, very first thing we need to do is for that we need to go to insert the survey data file, which I'm going to use is point file, so that's why I'm going to go to insert again. So from point import points, I will add the survey data, which is ENZD space delimited text file, and from this I'm going to create existing surface. So PENZD space delimited, so I have to set file format here, PENZD space delimited, PENZD space. So this is the matching file format, PNEZD space delimited. I'm going to add PNZD space delimited. I'll say open. This data is imported, point number, northing, easting, elevation, etc., and say OK. I'll say zoom extent so that the entire point file will be seen in the model space, and in tool space prospector under point group I can see all those points are imported. That is point number, easting, northing, so all these points are imported. Now next step is to create surface. So in tool space under prospector in surface I'll create one surface here, which is in surface layer C topo. In the information I'll write EG, that is existing ground. Existing ground, I'll give the description existing ground. For now I'll keep style and render material as it is, that is 2 meter and 10 meter background contours. I'll say OK. Now when I see in prospector tab under surface there is a EG is added, and I'm going to define it with this point file which we have just imported. The point group I can find that, so I'm going to add these all points and I'll say OK. So that way this surface is created. I'll just freeze the point layer so that I'll get some clean area to work on. Alright, so let's see in 3D view whether this surface is looking good or not, if there are any anomalies are there. So looks like surface is good. Now we'll say the next step will be creating the alignment. So for that I will take 2D polyline. I'll just draw some basic alignments. So that is the one, and then another one. I'll use nearest point somewhere in between here. Okay, so that will be the intersection point. So from this we'll create our alignments. We're going to use alignment from objects command here, which creates alignment from selected lines, curves or polylines. I'm going to select that. First of all I'm going to select this line, which is east-west line. Select that. It prompts me to create alignment. So I'm going to say enter, and here I can see alignment direction. So it goes from east to west, right to left. So it will start from right and it will go towards the left. Just keep as it is. I'll say enter, and with that this wizard opens. Create alignment from objects. In the name I will write road 01. So this will be proposed road 01. In general, we are not going to use any design criteria as such, but we are just interested in modeling intersection, a simple intersection. So we're not going to into the design criteria right now. We'll just set up site, that is none. Alignment style proposed, because that is the proposed alignment. In alignment level set, I'm gonna use major and minor only. There is no curve here, but I'll just keep that tick on, and it is existing entities. I don't want to erase it personally, but if you want to erase it, then you can keep it ticked. Right now I'm going to uncheck that because I don't want to erase that entity. I want to use that for further reference if required, and say OK. And now this alignment is created. Like I said, 00 is started from east, and as it goes towards the west, it is the last station. So one alignment is created. I hover over it, I can see that alignment here, name road underscore 01. Like that, I'm going to create another alignment. Create alignment from object, select that line perpendicular to this, enter. So here this arrow is showing from north to south. I want 0 to be started from south end, so I'll just reverse it. So now this arrow is reversed, so that station will start from this intersection point. Just for my convenience, I'm doing that. It doesn't matter if where that alignment starts, but it's my personal preference. Okay, so I'll give the name R2, then site 0, site none, alignment style proposed, everything will remain same. I'm going to uncheck this thing, major and minor only, alignment label set, so I'll say OK. So this 0 is here now, and we are done with the alignment. So surface is done, both the alignments are done, and we are going to design this intersection. So we are not going to use any default intersection wizard here. We are going to design our intersection with offset alignment and connected alignment. Okay, so our next thing required for this is profiles. I'm going to create profile, create surface profile. So create profile from surface for road 1. Selected surface is EG. I'm going to add that. Start and end elevations alignment is there. I will say draw in the profile view. This wizard will open. Create point view general. In general, that is the alignment name. Profile view name, I will say road 1. So this is proposed road 1. I just give some description here. Now most of the things are pretty set. Automatic station range, automatic station range, view height will be automatic. I'll just go next because none of the things are I'm going to change here. Band is also at standard. Profile hatch, I'm not going to do any cut fill area right now, so I'll just say create profile, and I'll place that here, so that way this existing ground profile is created. Okay, like that we will create profile for road 02. Select surface EG, add start and end stations, draw in view, general, alignment 2, profile view name alignment 2. Just say next, create profile view, and I will place down here, that is the road number 2. All right, so now we have got surface alignments and existing surface profiles. Now what we are going to do is we are going to design proposed road in this profile. For that, what I'm going to do is I'm going to go into the profile, and I'll say profile creation. I'll use profile creation tool to design my road in elevation. Profile creation tools. Okay. It is asking me to select a profile view. I'm going to select road 1 profile view. So here I'm going to give name proposed road 01. So proposed road 01 description. So this is a design profile. Design criteria I'm not going to use right now. I'm just following up with the standard one, whatever is there in this standard file. So in profile style, design profile, and I'm going to use a complete label style here and say OK. When I say OK, this profile layout tool is displayed. So here I'm going to use draw tangents with curves. I'm going to use this one to design my vertical proposed road profile. Once I select that, it is asking me to start point. I'm going to start with here, that is starting off the elevation here. It is pretty much flat, so I'll just pick and just try to be as close as possible to the EG. I'll go here, I'll go down there, go up, down there, and I'll close it here at the end, enter, and that way my proposed road 1 profile is ready. Okay, so same way I will do it for profile road number 2 profile creation tools, select profile road 2, and here I will say proposed road 02, proposed road 02, design profile, complete label set. Okay, same draw tangent with curves I'm using. To start with the starting station here, just follow the existing ground profile and just follow that one, and I'm going to end this somewhere here. Let me see where it ends, and it ends over there, enter. So that's proposed road 02, and this is proposed road 01. All right. Properties instead of road with this RD. Okay. just to keep both the names. So I'm just going to X out this. So at this position now, I've done my surface alignments, existing profile and proposed profile, vertical profile. Okay, so this will now good for going towards the assembly. So this is the point where I have to go to the assembly, and I'm going to create assembly. So create assembly here. So here first assembly I will say typical road cross section, CS typical road cross section. So just keep that as it is. In assembly type order, assembly style basic, all code style I'm going to use, and this is the layer. I'll say okay. It will ask me specify assembly baseline location. So the baseline location I'm going to keep somewhere here. With that, it has given me this location of the assembly. Now I'm going to activate the tool palette. Select tool palette, and now I can see tool palette, civilometric tool palette is open here. I'm going to use basic. Here I'm going to use basic lane transition. Okay, and I'm going to click it. So select the marker point with assembly. I'm going to select at this corner of this assembly, and that road is created. So I'm just say enter, and I'll select the sub assembly here, and I will see the properties here, these parameters. It is a right side, insertion point is crown, default width is 3.6 meters, depth is 0.2 meter, default slope is 2%, which is 2% downwards minus, and transition is hold offset elevation. So only thing I'm going to change here is change offset, because this transition I have to use this change offset and elevation, so that it will be good for me to target the offsets and elevations when I work on elevation. So I'm going to change this to change offset and elevation. So I don't want to hold the offset and change elevation, neither I want to hold anything. So I just want to change offset and elevation. So I'm going to change that one, and that's the only change I have made here. Okay, now we'll select basic curb and gutter from here, and use that. So that is selected. What else I need? I need a basic shoulder, so I'm going to use basic shoulder there and select that. Only thing is that I want this shoulder to be slope should be 2% and towards the road, so plus 2% I'm going to use it. And the width of the shoulder I just want 1.2 meters, or let's say 1 meter. So those are the changes I'm going to make here. And I'm going to add basic side slope and ditch day light, and I'm going to use that here. So that is the one side is created. Now let's see the parameters here. It is a right side, cut slope, fill slope, force slope. So a lot of parameters are here. If any design, as per your design, you can come here and you can check and change any parameter you want to change, just like we did for curb and sidewalk. All right, so on right side is ready. I'm going to select everything. Okay, I'll come here, modify subassembly. I'm going to mirror it with the central location here, that is this assembly point, assembly center, and about this. So this is my assembly sub-assembly center. So these sub-assemblies I have mirrored to the other side, and this is the assembly for the road that is done. So I'm going to name that is typical road cross section. I'm going to use same cross section for both road 1 and road 2. Okay. All right. So just to keep everything organized, I'll just keep a small rectangle here so that I would know where is my assemblies are located. So I'm going to use 3 basic assemblies here. So this is the first one. I'm just going to copy this to create another assembly. I'll just copy this here down, and one more. I'm just going to use 3 assemblies here in this exercise. Okay, so this one I'm going to use for half road. Okay, half road. So, and we're gonna in a minute we're gonna decide whether it will be right or left. Just leave it as it is right now and go to the plan so that we will identify the how the assemblies will be applied. So this assembly I'm going to that half road assembly I'm going to apply here in road 1, right? Road 1, and this road is starting from 0, that is from east side, and it is heading towards west side, that is this end. The stationing is from 0 from east to west, so my half road will be on the left side of the road. So what I'm going to do is I'm going to use this assembly. I'm going to say left. Okay, half road left. All right, now I'm going to get rid of this tool palette to get some clean area here. I might not need that, but if in future I need it, I can go back here and I can get it back. So anyways, so left side I don't want, I want to keep left side, so I'm going to get rid of all the sub assemblies here. Okay, and that is the left one. So this left one I'm going to keep. All right, so that is half road assembly. Okay, and now one more assembly we have to create, which we are going to use as for the connected alignment here. But before that, let's see how to identify those. So what I'm going to do is I'm going to use clockwise rotations in my connected alignment. So what I'm talking about, I'm just going to tell you in a while, but just to understand how I'm going to plan this intersection, let's say I'm going clockwise, right? So clockwise, so there will be a circle here. There will be a wait a minute, what I did. I'm going to use just a second. I'm going to use here start, center, end, 3 point. I'm just going to use this. Okay, so this type of circle, this type of fillet, I'm going to use that circular fillet. So, and I'm going to use clockwise rotation. So in clockwise rotation it will start from road 1 and it goes to road 2. So, and the lane will be on the left side of this alignment, and so that's why I'm going to use left. Okay, so, I'm going to use left one assembly here. Okay, so this is the left one, and this so this is the left, this is right. I'm going to get rid of that one, and I want only the lane here, left lane here. I don't want this daylight, that one, and that one I don't want. I just want that one. the curve on the right hand and the lane on the left hand. So, and I'm going to change the parameter here to 2%, which is draining towards the gutter. So that's how I want this to be, so that it will, you know, the water will flow towards the gutter here. So this is the gutter. Okay, so, and I'm going to rename this as a fillet assembly left. Okay, fillet assembly left. I'm going to rename that, and so that's it. So now I got my assemblies, I got my existing surface profile, proposed road profile, existing surface and alignments. Now we are ready for the corridors. Okay, so let's run a corridor here. I'll just go to the design tab, create design tab in the corridors. In this I'm going to name road 01, and the corridor style will be basic. Code set style will be all codes. The target surface we'll just do in a minute. Alignment, I'm going to select the alignment. So this is the alignment I'm going to use, that is road 1 alignment. So select profile. So propose RD1 profile I'm going to propose here. All right, and assembly. So here I'm going to use assembly. So this is the assembly I'm going to use, which is this one. That is typical road cross section assembly I'm going to use. And now this target surface is activated, so I'm going to use EG as a target surface, and I'll say okay. Everything good. Okay, it will show me this dialog box where baseline and region parameters RD01 is located. It's horizontal baseline, vertical baseline. This is RG, road cross section, and I'm going to start station, end station, frequency. So frequency, I'm going to use frequency of 5 meter everywhere. It's just my preference. Lesser the frequency, better is the result. Along the tangent, vertical baseline, along vertical curves, I'm going to use 5 meter. Offset target, again, that we'll see when it comes. We'll say okay. That way I'll say apply. I'll say reveal the corridor, and I got some warnings. I'll just say okay here, and I'll just get rid of this. And that way the corridor is created. So there is some issue with this corridor. Let's see what happened here. Object lever. Okay. So at the end it adjusts. Okay, what I'm going to do here is I will go to the corridor properties. The parameters, I will use okay, just a second. Properties. So let's see what the problem is. Okay. So we end that here. I'll just existing surface. Okay, we'll just say edit geometry. Okay, and we will use end here. Okay. That way it will be end there, and I will say okay, and go back to the corridor. It says we have to rebuild the corridor. Okay, and that fixed that problem here. So now we get a good corridor with, by 3D view we can check whether everything is okay on the daylight and alignment is perfect. So those daylights are also created along with the road width, curb and gutter. So looks like it looks fine. Okay, let's get rid of this profile layout tool. Okay, now same way I'm going to add the corridor for the road 2. I'm going to say road 2 alignment, select road 2 alignment, proposed road profile I'm going to use, and I'm going to use assembly again, same assembly I'm going to use. Okay, now road 2 is selected, assembly is typical road cross section, name is RD02, corridor style basic, code set style all codes, and target surface we're going to use EG. Everything is good. Let's say okay, and here baseline and region parameters RD02, frequency I'm going to use 5 meter along spiral, 5 meter vertical baseline, 5 meter. So along tangent, curve increment and along vertical curves I'm going to use 5 meter. Say okay, there are no curves here, but let's see. Apply rebuild corridor. So okay, and let's check what happened here again. The same problem is there. Starting is good, but at the end there is some problem. So let's check what is happening at the end. Okay. Okay, so we have to see. So let's geometry editor. What I'm going to do is I'm going to just lift a little bit up. I'm going to use extend that till end of this thing, and just lift a little bit up so that it will get some we'll also get some good percentage of road. Okay, here 9%. It's very steep actually. Anyways, we are going to adjust this elevation. Okay, so what we'll do is we need to adjust this, flatten it a little bit, and just move it up, just move it up, move it up, move it up, so that this slope will be flatter. Okay, it will not go much. Okay, Okay, that's fine. Now it will ask us to rebuild corridor, and that way it is taken care of. Now both the corridors are ready. All right, now what we have to do is we have to get this intersection clean up a little bit. I need some room to work in this. So what I'm going to do is I'm going to select the corridor, and I'm going to modify region, and we'll split the region. I'll split somewhere here. Okay, just and somewhere here. All right. Okay, so I have split that corridor in three. Just see this in corridor properties. So here you can see parameters. So there are three parameters, that is three baselines, right, central, and left one. Right one, central one, and left one. Okay. All right. So these are the. So now for that half road, in order to work on this intersection, what I'm going to do is I'm going to select road 2 corridor, and I'm going to drag it a little bit behind towards north, so that I'll get some area to work here. And here in road 1 corridor properties, I'm going to change the assembly to half road left. So that's the reason I have created half road left assembly. I'm going to say okay. In intersection, I'll keep still less intervals, so I'm just putting this frequencies setting up to 2 here, so that it will be more accurate. Apply, rebuild the corridor, and say okay. All right, so I get nice T-shaped area to work on here. All right, so looks good. Now what we are going to do is we are going to create a offset, connected line offset like here, so that we are going to use that to just a second, where is that? So like that. Okay, so this is how this intersection will work. So for that, let's the next thing, like I said, we are not going to use wizard here, so I'm going to use offsets and connected alignment here. So I'm going to select alignment, this RD2 alignment and RD1 alignment, and display order I'm going to bring it to the front. Okay, first I'll select RD1, and here I'll do offset alignment, road 1 offset name template, so it will take whatever that by default template it will take. Number of offset left is 1, number of offset right is 1, the incremental offset on left, so so this is 3.6 meter road width is there, so we have to use 3.6. That's the width of the lane. Okay, so alignment style offset, no label. Not going to create any label here. Widening criteria, I'm just keep not using any widening criteria, and create offset profile also. So create offset profile RD01, superimpose into profile view. I'm not going to superimpose on the profile one right now. The profile name though will be alignment name and alignment offset name, and the profile style will be since this is offset alignment, the profile style will be design profile, and say okay. All right, so these two alignments are created. These are the offset alignments. You can see offset alignment. Okay, the 3.6 offset I have taken because the lane width here, you can see the lane width here is 3.6 meters, default width of the lane. That's why I have taken that 3.6 meter offset. Now same thing we are going to do here at alignment, create offset alignment, and select alignment row 2, and just keep everything as it is, 3.6 create design profile, and say okay. So these two offset alignments are created now. Now I'm going to create connected alignment. What it will do is creates an alignment that maintains a dynamic connection to the geometry of existing alignments. So this will create the dynamic alignment, so I don't have to, if I make any changes to the basic alignment, it will automatically apply to these alignments once I refresh it. Okay, so I'm going to select create connected alignment here, and I'm going clockwise. Okay, so first northeast quadrant I'm going to take, and if I'm going to clockwise, then first this alignment, road 1 right alignment will be there, and then road 2 right alignment is there. So I'm going to select that one first, then second alignment I have created that one. Now pick a location for the connected alignment. It is giving me the prompt. So I'm in this quadrant, northeast quadrant. I'm going to select somewhere in this area. Now it is giving me some preview that how this connected alignment look like. So I'm okay with that. I'm going to say enter. So this connected alignment name, I'm going to give the name JN junction, and it is northeast, so JN northeast will be the alignment. So junction northeast is the name, is the description of this connected alignment. So the road 1, road 2, so this alignment is in between these two. It is a proposed one. Major and minor geometry points I want to highlight here because I want to know, I want this label to be displayed. Now in the design criteria, we are not going to do any design criteria, but in parameters we are going to use circular fillet. Okay, curve radius, since it is 3.6 meter lengths, I'm going to use 10 meter curve radius, and offset, we don't want any offset on either side, we just want exactly at the center. So 0, connected overlap will be 10 meter, and the preview is like this. See, it is going clockwise. This radius is 10 meter, and the offset is 10 meter. The forward and backward offset both are 10 meter. I will say okay, and it has created this alignment. Okay, so this is JN northeast alignment. Same way I'm going to create Just keep this cell scale to maybe 250. Okay, so that it will be more cleaner. All right, now I'm going to move towards channel alignment, create connected alignment. So see, I'm going clockwise. So here in this case, I'm going to clockwise. So first alignment I have to pick is road 0 to left, and then I'm going to select road 01 right alignment, and the location connected alignment I'm going to pick here. This preview is giving me a good preview. I'll say okay, and here I'm going to use JN northwest, JN northwest. So junction northwest, that's the quadrant I'm going to select. So junction northwest, connected in road 2 left and road 1 right. Alignment style proposed, label major minor. Design criteria, I'm not going to use anything. Parameter, I'm to use circular fillet. I'll just keep curve radius 10, right and left offset 0, connected overlap 10 meter preview. So this is the clockwise one, and I will see so connected profile will be that one. Let's say okay, and this connected alignment is ready. Okay, all right, now our alignment is ready. Now what we have to do is we have to add these alignments, these corridors, this alignment into this corridor, which is this one, that is road 1 corridor. I'm going to select the corridor and I will say add baseline. So when I say add baseline, so baseline name will be here, and the alignment will be first of all I want to select the northeast alignment. So I'm going to select northeast. I'm going to say okay. All right, so we'll say okay. For the next one I'm going to select this one. Sorry, select profile. Oh, select profile. So that is JN northeast. That is the profile I'm going to select. Okay. So when I say in the profile properties, this baseline is added. Now I'm going to add baseline. That is northeast is done. Now northwest I'm going to add. I'll say okay, and northwest alignment is also added now. And here the profile I'm going to select is northwest, and apply, rebuild the corridor. Okay, so I have to add region here for this new baselines. So the fillet A left. So here the vertical baseline is northeast, horizontal baseline is northeast, vertical baseline assembly we are going to use fillet A left. Okay, fillet A left I'm going to use. Here also I'm going to add region. Okay, fillet A left is the assembly I'm going to use. I'll say apply, rebuild the corridor. Okay, and see both the corridors are added in this corridor. Now I'm gonna go ahead and edit the frequency now. So here for northeast corridor I'm going to use frequency 1 meter in tangents, 1 meter in curve increment, 1 meter in along spirals, and along the vertical curves 1 meter. Say okay. Same thing I'm going to use here, 1 meter, 1 meter, 1 meter, 1 meter. Okay, and say apply, rebuild the corridor. Okay, okay, it looks good, right? Okay, now we have used this fillet A left. So now you know why I have taken fillet left uh, assembly here, because my um, lane is on the left side here. So here my lane is on the left side. So that's, and by I'm going clockwise. So here left lane, here I'm going clockwise. So here the left lane is on the other side. So that's why this stationing of the connected alignments are chosen. Okay, guys. All right. Now let's work on the targets. So select the profile, right click, corridor properties. Now here in northeast, we'll select the target. Okay, target. For the offset elevation, transition alignment, we're going to use road 1 and road 2, right? And for the profile, we're going to use proposed road 1 and proposed road 2. So those are the profile elevations I'm going to follow, right? And say okay. Before that, we have to add the surface target also. So for all, I'm going to choose EG as surface target and say okay. Oh, before that, we need to see for the offset and elevations. For transition alignment, we are going to target to the nearest offset. Okay, and say okay. And for the transition profile also, target to the nearest offset, and we'll say okay. Okay, and we'll say apply. We go in the corridor. Okay, and that way this northeast corridor is set up and looks good. Same way we'll set up northwest. Let's go back to corridor properties. The northwest, I'm going to add targets here for the transition alignment, road 1 and road 2. For profile alignment, propose road 1 and propose road 2. Okay, in the surface, for all EG, I'm going to set EG just like the other quadrant. Say okay, apply, rebuild the corridor, say okay, and that way I see both the corridors are updated and it has picked the correct targets. Let's see how it looks in object viewer 3D view. Just see in 3D here. Okay, looks good. Some of the links are not correct, so let's go ahead and add some links here. So I'm going to do select here. I'm going to add some sections here for the better accuracy. So I'm going to add one here, another here, here. Wherever there is a less frequency, I'm going to add that. That's fine. So it will give a smooth surface, and also there will be more sections targeting that point, so it will improve upon the, let's say, enter. Same thing I'm going to do, add sections in this area, in the northwest zone. Here I'm going to add This looks okay now. Okay, now let's see. Now let's reveal the corridor. Okay, here 3D and so isometric or southwest isometric. We'll zoom in. Looks like there is some target issues there. So let's check the corridor properties again in the targets. Okay, target alignment RD1, RD2, profile, proposed road 1, proposed road 2. Okay. Corridor properties, target, transition, proposed road 1, proposed road 2. Okay. Oh, okay. So, yeah, I know what is the problem. Okay, so this problem is due to one mistake I have committed. One mistake I have committed is that I have not matched the starting of the elevation to the elevation of this thing. So let's correct that. Okay, we are going to use the profile station from plane to identify the location on the road 1 where it meets. Okay, so use transparent command. Let's use line, and in the transparent command I'm going to use profile station from plan. Select profile. Okay. Intersection. This is the intersection of this point here. Okay. Now specify the elevation and just select 146 as elevation. Specify the station along. Okay, so this is the line where this is the line on which the road to connects. So we have to use elevation of this point on this elevation of this proposed alignment on this RD1 profile. So I'll just add station elevation and I'll just pick that point, another point, and that is the station and elevation, which is 161.21 is the level of intersection. So at the intersection elevation is 161.21, and this is the starting point of RD02. So I have to edit this elevation with 161.21. So in geometry editor, in profile grid view at 00, we have to edit this. We have to put it 161.21. okay, enter. Right, so now it is matching with the right. So this is 161.21. Starting elevation is matching with the intersection elevation 161.21. So by doing that, it is now asking me to rebuild all the corridors. I'm going to rebuild those corridors, And now if you see the in object viewer, north southwest isometric, this looks perfectly fine now. See, it matches pretty good, right? And that way this intersection is done now successfully. Now we'll just adjust these corridors back in their position. Now we'll just move it to end of this. Okay, just move it back to the end of the junction. So everything matches perfectly here, looks good. And move that also to this point here. Alright, so this matches pretty good. I'm going to specify end of here. And that way my junction is good. Let's see how it looks in 3D view. Object viewer, southeast elevation, zoom in window, just pan it a little bit, and that's it. Looks good with daylight perfectly matching, and most of that is in the cut, so you can see it's pretty good. Okay, so close it. We'll just quickly add a surface to it and see how it looks. So here I'm going to select profile, and I'm going to do corridor surface. Okay, just create a corridor surface RD01. The specify code is at the top, and just add the top code. Boundaries, corridor extend to the outer boundaries, and apply, build the corridor. Okay, surface is added here, RD1 surface is added here. Now some corridor surface, need to add surface RD2, top, add boundaries will be corridor extend boundary, apply, build the corridor. Okay, and this surface is added here. I just freeze the corridor so we could see the surface, proposed surface. Just freeze the stationary and the corridor. That way this corridor is the corridor surface is added. And just select this and just orbit it and see how it looks. North, southeast, and zoom in, and looks good, right? All right, so that's the way we have created one simple corridor intersection with connected alignment and offset alignment. That's it, guys. Thank you for watching.